Welcome, dear friends, to the 5th tutorial on how to build a transistor CPU. I would like to refer to a slide which I showed in the introduction, and what is marked in yellow is already done. So we are really over the halfway point. We started with making general purpose registers A and B, which hold the data. We built an ALU which can at least add numbers. I'll teach you how to subtract also. Then we went to the other end. We made a oscillator, a program counter, which can also jump. That means that in a program you go from step 1, 2, 3, and then you want to go to 16. Now comes an important step. We have the program counter, and we need to make sure that every number on the program counter identifies a single line of code. We can also look at it from the other way, from the A and B register. These have buttons that you can push on. If you push A out, then A will go out. If you push in, it will load the value in. How to combine the program counter to the control of the computer. For that I need to explain two things. One is the ROM board, which I will start with, and secondly is the demultiplexer. First, the ROM board. Imagine a board that is organized around two dimensions. One dimension is the clock cycle, the state of the clock cycle, 1, 2, 3, 4, 5, 6, and the other one is connected to the ALU and the A register and the B register to pass on signals when they need to operate. By shortcutting this board over the two dimensions with diodes, you can give signals to the system. For example, here in clock cycle 000, S1, S0 and S2 are connected. In clock cycle 001, S1, S2 and S3 are connected, and you can make your own program by soldering diodes into this program board. Here is a picture of a real ROM board. You can see it's 8 clock cycles high and 16 signals wide. I think I need 16 clock cycles to run the whole computer. And you know, we limited the computer to 64 clock cycles. Thus, for a complete program, we will need 8 of those boards. The signals, 16 of them, stand for something. And here you can see an overview of how I plan to do this. One thing I'm not sure of, that is if I put in a jump on 0. I haven't built it yet, so I don't know yet. But these other 15 are things you really need to make a computer, I guess. Please meet the 3 to 8 line decoder. You start with a 3-bit binary code, which can lead to 8 possible solutions. And how it's built with the 3 input NAND gates, only one is off and the rest is on. If you do this in 2 dimensions, you'll get a matrix of 8 by 8 crossings, and if you put the 6-bit binary program counter to one side and implement it into this grid, you'll find out that only one crossing will be 0, 0. If you place now a NOR gate on the crossings, then every value of the 6-bit wide binary counter, program counter, will result in just one signal. 64 signals for 64 values. Okay, now the practice. On the left you see the program counter. It's now in a higher value, but it is going to turn around and turn to 0, 0, 0. What you see is I have a signal board which will give out a signal. One moment please. Here it is. Compare it with the clock. It's value 4, 5, 6, 7, 8 compared to the clock. I'll show it again. Compare the value of the clock on the left with the signal board in the middle. It gives a signal when the first 8 lines of code are run. Now I'll switch it around for the second 8 bits. So the first 8 bits will do nothing, but when it reaches 8 now, it goes to 9, 10, 11, 12, 13, 14, 15, 16. I'll show that again too. Value on the clock is 0. First 8 bit nothing happens, but the second 8 bits will be shown on the little signal board. 9, 10, 11, 12, 13, 14, 15 and 16. I hope you could follow it. The boards you will need for this circuit are in the Google Drive, and the bottom of the dual demultiplexer is shown here. So it enters 2 times 3 bits and gives out the demultiplexed 8 signals. The next board that you will need is the board with the 32 NOR gates, and here is how you attach them. Lastly, you find the pinout if you put these boards on a perf board, as it is in the videos I showed you. This will be the bottom, and this is how to connect them. For the last chapter of this tutorial, I programmed a board. What it does, it gets the value out of the Z ROM register and places it in all available registers. So that is ALU A, ALU B, jump register, A and B register. And it serves the purpose that I can see that everything works well, but also that I know where the least significant bit is. If you build new, please take care that your LSB is always on the right or always on the left, but not, as in my case, mixed. You can see me starting up the computer. It takes a while, but the lights will come on shortly. And then in the first 8 steps the computer will do nothing. I programmed it that way. So 6, 7, 8. Now it has to do something, and you see that the value 1 is going to ALU, ALB, the jump register and the A and B register. Play this video once again, and that will be the end of this tutorial. I thank you very much for the nice reactions. If you already start building, please share with me, and see you next time in 2 weeks approximately. Bye!